Today our topic is transistor CB configurations. So transistor CB configuration means common base configuration. So before going to that, let us briefly recapitulate what we discussed in the previous class. So previous class we talked about basics of transistors. So transistor is a semiconductor device which consists of two junctions and three terminal. So two junctions, namely we call it as emitter base junction and collector base junction. So three terminals are emitter, base, collectors. So transistor is two types. One is PNP transistor and other one is NPN transistor. Okay, so emitter, base, collectors, these are differently doped and different sizes. So emitter is a heavily doped because it emits the electrons or holes. Collector is lightly doped, base is lightly doped, collector is moderately doped. Whereas come to sizes, emitter is medium, collector is large, and base is very small, whereas in size wise. Okay, so these transistor operations also we seen what is the NPN transistor operation whenever first junction is forward bias and second junction is reverse bias. That is emitter base junction is forward bias and collector base junction is reverse bias. We will see what is the operation in NPN transistor and PNP transistor. Okay, today we will see the configurations. So different configurations are there in transistors. So transistor configurations, one is common base configuration, common emitter configuration, common collector configuration. So common base configuration we also called as grounded base configuration. Grounded base configuration. Grounded base configuration. Okay. So first today we will see common base configuration. So what do you mean by common base configuration means? So base is common to both input and output side. Here two transistors, one is PNP transistor and other one is NPN transistor. So we know that. So this one is emitter base junction and this one is collector base junction. So two junctions in transistor. Similarly here also same emitter base junction and collector base junction. Here two voltages or two batteries or two junction voltages. See, first one is forward bias. This is emitter base junction is always forward bias. Collector base junction is reverse bias. Similarly, this one is forward bias and this one is reverse bias. Okay, this is the connection. So base is common. Here base is common. Okay. See, whereas the symbol of transistor, so this arrow direction is forwarded to the base. We call it as PNP transistor. This current direction we also called as conventional current direction. Okay, this is out, forward to outside. So this is NPN transistor. Okay, three terminal. One is emitter, base, and collector. So common base terminology is derived from the fact that the base is common to both input and output. See, here this is the base. So this is the emitter. This one is the emitter. This one is the base and this one is the collector. You can clearly observe this. So base is common or it is grounded. Actually, every circuit it is a grounded, here not shown. So this base point is common to both input and output, both input and output. So this one is forward bias, this one is reverse bias. Okay, here also same. So this is for which transistor? So current, conventional current direction is out to the circuit. This means it is a NPN transistor. First one is NPN transistor. Second one is PNP transistor. Second one is PNP transistor. Okay. Here also base is common to both. This one is the input side for this circuit. This one is the output. So this base point is common. Okay, common to both the input, and this point is also common to both output. Okay, that's why we are constructed like this. So base, one terminal is common to ground, one terminal is common to ground. That's why it is a grounded base configuration also. Okay, so sometimes in exams their questions may differ. Explain about common base configurations. Sometimes they will ask explain about grounded base configurations. Both are same. So terminal is grounded. Here base terminal is grounded means it is a grounded base configuration or common base configuration. Okay. See, so this is a NPN transistor. So this is the base. So we know that, so this is two junctions are there. This is a emitter base junction, emitter base collector. So first one is emitter base junction. So how to measure voltage here? What is the voltage? This is the VEB. So VEB means emitter base voltage. So junction voltage, emitter base voltage is the junction voltage of the first junction. Here, which junction? This one is base collector junction. This one is base collector junction. Okay. So base collector junction means what is the voltage? Junction voltage VCB or VBC. Both are same. So VCB means voltage across collector base junction or voltage across base collector junction. Both are same. So this VCB is identical to VBC also. Both are same. So C for collector, B for base. Here also same. B for base, C for collector. Okay. See here. So this is the emitter base voltage. Here also. So this one is the base. This one is collector, means collector base voltage. So here we are given some battery. Input side battery. This one is the input side battery. This one is the output side battery. Battery is nothing but we are giving input. It may be signal, voltage signal or current signal we are given. Okay. This is the practical way of representation. Okay. Next, how to measure the voltages first junction voltage how much, second junction voltage how much. So we know that junction means it formed PN junction. See how it forms base, here base and here emitter. So junction is nothing but PN. So PNP. So here one junction, here one junction, NPN. So here how to measure junction voltage means by using multimeter in the lab. So one terminal is connected to positive, other terminal is connected to negative. Then we will find how much voltage exists between base and emitter terminal. So this voltage we call it as VBE. VBE means base emitter voltage. Base emitter voltage. Okay. So generally base emitter voltage is very less or very low. Here base collector voltage. So this is also one junction here. This one is emitter base collector. So this junction we call it as emitter base voltage, this one. So this junction we call it as base collector junction. So this is the base and collector. So this junction is called base collector junction. So generally base collector junction is very high. Okay. So this is the practical way of connection in ADE lab. See, it is a transistor. This one is transistor symbol. Yes. So it is the arrow conventional current direction is outside to the base. That means it is a NPN transistor. It is a NPN transistor, first point. So transistor is a three terminal. One is emitter, base, collector. So emitter, base, there is a one junction. So that junction voltage can be measured by using 1 voltmeter. So VEB. VEB means emitter base voltage. And also here current. So current is for ammeter. This is called ammeter. We will measure the emitter current. Okay. Similarly, right hand side. So there is a other junction. So this junction is called as base collector junction or collector base junction. So this junction voltage can be measured by using other voltmeter. So voltage across base collector junction is VCB. So what is the collector current? Collector current is measured by using ammeter. So this one is ammeter. See, you can remember one thing. So in any circuit, in transistor configuration, we are always connected voltages at parallel, current ammeters at series. Okay, here you can see. So this one is the parallel connection. This one is also parallel connection. So ammeter is series connection. Here also ammeter is series connection. And left hand side and right hand side, one battery and one resistance, source resistance. This one is source resistance or emitter resistance, RE or source resistance. Here RC, collector resistance or and VCC. So this is the practical circuit in the lab. Okay, I will repeat, listen carefully. So first one is the transistor symbol. So it is a emitter base collector, three terminal. So base is grounded here. Base is grounded. That's why it is a common base configuration or grounded base configuration. So here first junction voltage measured by using one voltmeter, second junction voltage by using other voltmeter, and emitter current by using ammeter, collector current by using ammeter, and one battery and resistance combination is also connected here. So this is the common base configuration. Practically, common base configuration circuit look like this way. Okay. So in common, we know that what is the purpose of transistor? Transistor means transfer of low resistance to high resistance. So it passes the signal from input to output, from low resistance to high resistance. So we will see some factors. In common base configuration, current amplification factor alpha. So the ratio of change in collector current to the change in emitter current at constant VCB is known as amplification factor. So you can see change in collector current to the change in emitter current. What is the output side? So left hand side is the input, right hand side is the output. So that means alpha is equal to change in output current. What is the output current? Change in output current means, so output current, right hand side is which current? IC. Change in IC by collector current by change in input current. What is the input current? Left hand side IE. So this is the IE. Change in output current by change in input current at constant VCB. At constant VCB. This is fixed. This is fixed for 1 volt, 2 volt, 3 volts like that. We will get alpha is equal to change in IC by change in IE. So practical value of alpha is less than the unity. It is always less than the unity, from ranging from 0.9 to 0.99. Okay. So in common base configuration, alpha is the amplification factor. So output current by input current. So expression for collector current. We know that, first class we know that. So emitter current is equal to collector current plus base current. Why it will get, already explained. See, I will repeat once again. So this is the emitter, base and collector. So whenever bias is applied, forward bias here, forward bias, and here reverse bias is applied. Okay, so emitter means it emits electrons. So for example, this is a NPN transistor. So N means electrons. So it emits the electrons and cross to the two junctions and reaches collector. So some electrons, so it is a P means holes are there. Some electrons are recombined with holes here, so that base current exists. So collector emitter current is equal to this base current and collector current. Okay. So in second side, second junction is always reverse bias. Because of reverse bias, there is a minority charge carriers. Minority charge carriers passes to the collector base junction, which actually constitute a leakage current. Leakage current is very less. So leakage current is denoted by ICB0. So leakage current will occur at collector base junction, because it is a reverse bias. So leakage current is always very less. So total current, total collector current is equal to leakage current plus alpha IE. How we will get this one alpha IE? So we know that alpha is equal to IC by IE. Okay, IC by IE. So what do you mean by IC? IC is equal, from this equation, IC is equal to alpha IE. So collector current is equal to alpha IE, we know that. But some reverse leakage current is also exists because of reverse bias at the junction 2. So therefore, collector current is equal to alpha IE for additional some leakage current ICB0. Okay, so collector current is equal to alpha IE plus ICB0. Okay. So what are the characteristics of common base configuration? Actually, one thing I want to tell you here. See, in input characteristics means, we will go to this one. So input characteristics means, so this is the input side. Input side means left hand side. What are the input characteristics? Here voltage and current. That means VEB is the voltage and current IE characteristics. Input side is the this one VEB and current IE. When VCB is constant, when VCB is equal to some constant value 0.1 or 0.2 or 0.3 like that, this is called input characteristics. What do you mean by output characteristics? So output characteristics are, these terms are there. Output characteristics are VCB versus IC graph. When IE is equal to, when IE is equal to constant. Okay, I will repeat. Input characteristics means, what is the input characteristics? So input side is, this is the voltage VEB and IE. When VCB is constant, output characteristics means these are the output character VCB versus IC when IE is constant. I will explain clearly in this graph. See, Input characteristics means VEB. So VEB means emitter base junction. That is left hand side, emitter base junction or base emitter junction. So what is the current in input side? IE means emitter current. Okay, when VCB is equal to some constant value. So first we are putting VCB is equal to 0 volts. How to put VCB is equal to 0? By varying IC current. Okay, by varying IC we can minimize or we can put some fixed value to VCB. Okay, and varying VEB. VEB, see here VEB and here VBE. What it means, both are same. Why? Intentionally I wrote like this because some students they may doubt what is the difference between VEB and VBE. Both are same. Why? So this voltage we call it as emitter base voltage. This voltage also base emitter voltage. Both are same. That's why I wrote like this. So VBE versus IE characteristics is called as input characteristics. This is the input characteristics. So input side. When VCB is equal to constant. See, you can observe y-axis is IE and x-axis is VEB. See, IE is increases rapidly with VBE or VEB. So it means resistance is very small. Okay, IE is almost independent of VEB or VCB. Okay, so emitter current is increases rapidly. So like this perpendicular line rapidly. Generally, it is look like PN junction diode. PN junction diode. So it is similar to PN junction diode characteristics because here this is the first junction characteristics when VCB is equal to 0. Okay. Now we will go for output characteristics. What do you mean by output characteristics in this figure? So output characteristics means, so this is the emitter, this one is the collector, this one is the base is grounded now. So this one is IE current, this one is IC current, so this one is IB current. So what is the output characteristics? Output characteristics means right hand side. So right hand side junction is VCB or VBC. Okay, here VBC or VCB. VBC versus IC when IE is constant. See, when IE is constant here, IE is equal to 5 milliamperes, IE is equal to 4 milliamperes, IE is equal to 3 milliamperes, and IE is equal to. So these are the different IE value, different constant value. First, output characteristics, what we do, by varying the VEB voltage, by varying the input first junction voltage VEB voltage, we have to fix the IE value. Whenever VEB is varying, means voltage across emitter base junction voltage is varying, IE it will vary. So by varying this VEB, we will put IE is equal to, first time we will put IE is equal to 1 milliampere. IE is equal to 1 milliampere first. After that, varying VCB and IC. Means whenever VCB is varying, means IC is also varying like this. Okay. Next, after some time, VEB, by varying VEB, so you can put IE constant value at 2 milliamperes. IE is equal to 2 milliamperes. Then you have to vary VCB. You have to vary VCB again. Again, this wave is like this. So it is some linear up to this. It is a constant. Next, third time. Third time, what we do, by varying first junction voltage VEB, you put IE as 4 milliamperes. Then varying second junction voltage VCB and note down the IC value like this IC value. So this is called output characteristics. Okay. So input output resistance of common base configuration. So input resistance is nothing but what are the input side means resistance is nothing but voltage by current, change in voltage by change in current. So input side is first junction voltage, VBE voltage by IE current. Right hand side output characteristics. What is the output resistance? So output resistance means voltage by current. What is the output side voltage? Collector base junction voltage by collector current. Okay. See, this is the input side. Input resistance means VBE, input junction voltage, change in input junction voltage by change in input current or emitter current. Similarly, output side. So output side change in base collector voltage by change in collector current. This is called output resistance. This is called input resistance. Okay. So I will summarize what we discussed in this class. So we discussed transistor configurations. So transistors configurations are three types. One is common base, common emitter, common collector. So first we will see the common base configuration. Common base configuration is nothing but base is common to both input and output side, or it is a grounded base configurations. Okay. So here two type of characteristics are there, input type characteristics and output side characteristics. So input side characteristics means it is versus emitter base junction versus emitter current. When output voltage, junction voltage VCB is constant for different value, output characteristics is nothing but it is the curve between VCB, second junction, collector base junction voltage versus collector current when IE is constant for different value by varying VBE. So that is the common base configuration, and also we are finding some input and output characteristics. So here amplification factor is always less than 1. So amplification factor is nothing but change in IC by change in IE, alpha. So in CB, common base configuration, amplification factor is denoted by alpha is equal to change in collector current by change in emitter current. This is called amplification factor. Okay. Okay, thank you.